I want to speak about the rise of modern artificial intelligence with deep learning, because a lot of things went on in the last years, and I think it's important to understand for the people what was actually happening, what was the reason why we are here now where we are. So there were actually 3 prerequisites required for modern AI. The first one was there was data required to be everywhere, a lot of data. This was the first prerequisite. And of course, you can imagine, because of internet, we have now data everywhere. But even more, if you look at machines and sensors nowadays for IoTs, they generate even more and more data. And also interesting is here that we have a lot of unstructured data, which was very difficult to process before. But nowadays, it was much easier. The second prerequisite that needed to happen was it needed to have a time for GPU computing. It needed to have to come. This happened because the CPU, if you look at the CPUs itself, they were, with the next generation, they were just gaining a little bit more performance. And if from one generation to the next, it was maybe 10% or 15% or 12%, it was just not really a jump ahead. So people were looking for other possibilities how they can get performance. And they found out that GPUs was a good way how to use and get performance. A GPU is mainly just a processing unit which has much more cores than a CPU, but I will come to that later. The third prerequisite that we required, we needed to have a new computing model. Mainly it was using deep neural networks going deep. And compared to before, you used expert systems where you really tried to algorithmic explain something. You try to algorithmic explain how you see a face. You try to say, okay, here is a nose, here is an eye, or here is a mouth. And now with the new computing model, actually with deep neural networks, you leave this up to the computer to define and to learn. So these were the 3 prerequisites required. So what happened now? And I think now that's the interesting part. What happened now that we are here where we are now? Why is suddenly artificial intelligence so an important topic, and why is it really, let's say, exploding because of interest? I want to give here quite a good insight into it so that you understand the reasons. So let me first give you a quick side remark. 1999, it was the graphic processing unit which was developed. The GPU was mainly first used for graphics. The idea behind the GPU is that the mathematics used for graphics and to display graphics, the vector mathematics needed to be parallelized, and it's a simple mathematics. It's mainly vector mathematics, and it can be very nice parallelized. So in the beginning, these GPUs were only used for graphics. But then actually something interesting was done at NVIDIA. It was around 2006. They invented CUDA. And CUDA was just a framework actually that you could use the GPU as well for other compute than just for graphics. It was a framework which opened up the processor for compute tasks. And what happened next was it was quite a pull into the supercomputing area, but it was not yet there yet. First, it needed to develop further. It was required that it could use also single precision, double precision data to be performed, to be used. And when this happened, it led actually to the supercomputers embracing the technology, the GPUs. And now if you look at the supercomputers nowadays, if you look at the top 5 or top 10, you see that every second supercomputer has GPUs in it. So the technology was embraced there already quite earlier. This was an important step to understand so that the people could use GPUs for compute. And now a couple of things happened that made the market explode. I think the first important and interesting thing that happened was that there is a competition called ImageNet. ImageNet is actually a competition where the computer needs to guess what kind of objects are in an image. It's like a classification, you know. You give them computer an image, and then it says, ah, that's a dog, or this is a guitar in it, and it tries to figure out what is in it. And before, it was mainly expert system which have been used here. So this means a computer programmer needed to design the whole world, or let's say the objects, and tell, okay, this is a guitar, this is a man, this is a woman, this is a dog, and so on. You need to design it. You need to give some cues for it. And these expert systems, they worked somehow, but they were not just good enough. So it was around 2012 when somebody tried first time deep neural network, an artificial neural network, to use this task, and trained a network actually to do that. And this was the first, let's say, interesting step what happened, because it was a big step forward. Suddenly, not accuracy stepped up 20% or more to what it was before, which was a huge leap forward. The second thing that happened, it was still very computer intensive, and it was mainly done at this time with CPUs. So the second thing that happened was, again, around 2012, after 2012, somebody in Stanford actually built a machine which was using, again, deep neural networks, but they were using GPUs mainly for that. And they could bring down to do the task before with 2,000 CPUs with just 12 CPUs. So this news again sparked quite a huge interest in community. And what then happened actually is just history. I think you saw it if you were reading the news. The two things. So one thing, first step, there was deep learning applied to this image classification, and it made a huge step forward. But what was really remarkable was that at some point in time, when these neural networks were getting better and better, and GPUs could be used to have even more power, at some point in time, the computer or the artificial intelligence was better or got better than a human. You need to think like this. If you need to look through images, I need to see these images and classify objects on it. Humans, they do error as well. They get tired, they lose interest, they're not here, to concentrate it and so on. So they make errors as well. If you do like computer, they not get tired. And so that's the reason why at certain point in time, the computer was better to identify objects in these images than the human. And this was a big breakthrough. The second thing that happened was, you heard maybe also about the AlphaGo or the Go game, where artificial intelligence was used. So in Go, it's also quite an interesting game, because in Go, you cannot just calculate all the positions in advance. It's just too many. So you need to apply certain intelligence. And this was also done by using deep neural networks and GPUs on the back end. After this, actually, something very interesting happened. It was like, I call it a Cambrian explosion sparked by deep learning and GPU. A Cambrian explosion is actually a word which I did land from development of Earth and life on Earth. If you look back millions of years, when there was life developing, first there was very simple life, and at some point in time there was enough oxygen there to actually develop more and more complex life. And even this life developed further, got bigger, they even started to eat themselves and so on, like predators were included. They came out of the sea and so on. And suddenly a lot of new species appeared. That's the area of the Cambrian explosion. And it's exactly what we see now in the whole area of deep learning with GPUs and AI. We have so many applications at the moment which come up, and this is just solely because people have found out what they can do with it. So First, when this Big Bang happened, actually first the researchers were embracing the technology, as you can imagine, but it sparked off quite fast to the core technology providers or in Silicon Valley. For example, Facebook did their Torch framework, Google did their TensorFlow framework, Microsoft did the Cognitive Toolkit, and so on, all based on this technology to how you can better use deep neural networks with GPUs and make it just simpler. And the next step that happened was platform providers jumped on it. So Amazon Web Services, IBM Watson, Google, and so on, and Microsoft Azure, they were using this GPU technology on the back end and implemented in their cloud and added on top their own frameworks. So as a next step, again, the startups came. There are a lot of startups, they saw the possibilities and they were actually embracing the idea and technology. And they started to do a lot of projects, quite advanced projects with deep neural networks. And now we are at the next step. We are now at the point where we're crossing the chasm from startups or early adopters to actually enterprise companies. So at this point in time now, really deep learning is sweeping across many industries. You can look at internet services like image or video classification. Look at Facebook, right? It's the face recognition is all done with this technology. You can go to medicine. You can do the MRI images, cancer cell detection MRI images. So the computer is looking through all the MRIs and finding anomalies and telling where there could be cancer. I have another startup who actually does a scan on the retina and then can tell you, depending on the retina, what they see on your eye, whether you have a disease or not, like an early detection of diseases. The same, you can look in media and entertainment, the video capturing, or just imagine real-time translation is now possible. Before you had really to have somebody to look at it and then translate it simultaneously. Nowadays, actually, you can just take the movie, let somebody speak, and then let actually the computer translate or transcribe, so that you see below just a transcription of what the moderator or the person is saying. And this is all done with deep neural networks nowadays. The second or the next one would be security and defense area. A lot of things can be done with face recognition, with video surveillance, and so on. You can detect if somebody is walking into some area. You can use it for business intelligence things. For example, you look where the hotspots in traffic congestions and so on. Another area, and the last one, is the autonomous machines. You did see a lot of upcoming announcements recently, like all the cars, all the autonomous cars and driving would not be possible without this technology. Actually, it's a heavily compute power which you require to in real time to analyze the video signal, and it goes through a neural network and makes its decision. So this shows you actually we are not just modern AI with deep learning is already actually everywhere. Sometimes actually just don't see it yet, but it is here. The key here with modern AI and deep learning is it required a new computing model with deep neural network, which again required parallelized computing. And that's why actually NVIDIA was so dominant in this market now. At NVIDIA itself, we help our customers with this technology. We have our own deep learning institute where we can help you and guide you with hands-on workshops at this as well. Just one last thing, there's an upcoming conference. It's called the GPU Tech Conference. Just in case you want to participate there, it's a good possibility to connect with partners with customers and as well with our technicians, and to update you on the technology. Again, there is a Deep Learning Institute, which also you can get more info about using these technologies. I hope I did give you now an overview about why are we here now? Why did it spark such an explosion of new applications? And you understand a little bit behind it also that there is, of course, some people say it's a hype, but I can tell you, I see so many applications nowadays. So it's not just a hype. There are real applications which are doing things which have not been possible before.